This is Test 3 Review, Part 3. Number 16, like number 15, is asking you to find all zeros, but notice this is x to the fourth. When it's x to the fourth and you look at the calculator, you must see two places where the graph crosses the x-axis. So if you type this in your calculator and take a look at your graph, you will see that it crosses at -1 and 6. Also, you can double check that it really is -1 and 6 with your calculator by using the table function. If you look at the table, you will see -1, 0, and you will see 6, 0, which tells you for sure those are your zeros. So we're going to do synthetic division with -1 and these coefficients, checking, of course, to see if you need a placeholder, which we do not. Bring the 1 down. -1 times 1 is -1, adding get -6. -1 times -6 is +6, adding get 4. -1 times 4 is -4, which gives us -24. -1 times -24 is +24, which gives us 0, which verifies that -1 truly is a 0. Now this is where things are a little bit different. This started out x to the fourth. That means this depressed equation is actually x to the third. That's not going to do me any good. I need it down to x squared so that I could either factor or use the quadratic on it. So from this setup right here, we're going to do synthetic division using 6. Don't go back to the original coefficients. Use these new depressed coefficients. So bring the 1 down. 6 times 1 is 6, gives us 0. 6 times 0 is 0, gives us 4. 6 times 4 is 24, which gives us 0, verifying that the 6 really is a 0, like the calculator told us. Now this stands for x squared plus 0x plus 4, which, if I write that a little better, is just x squared plus 4 equals 0. That does not factor. I could use the quadratic on it, but that's more work than necessary. Notice all you have is an x squared item and a plain old number. So let's subtract the plain old number to the other side. And now we have x squared equals -4, which means I can use the square root method. Take the square root of both sides. Square root of x squared is x. I pick up a plus or minus here, and the square root of -4 is 2i. So all of the zeros listed together would be -1, 6 that you found from your calculator, and plus or minus 2i. Number 17, similar problem. You're going to put it in the calculator. And when you put it in the calculator, you will find that -1 and 4 are your zeros. Those are where the graph crosses the x-axis. So I'm going to do the exact same steps I just did. Start with -1. And there's nothing special about starting with -1. I could start my initial synthetic division with 4. I just happened to start with -1 because it was the first thing I wrote down right here. So here are my coefficients. I do not need a placeholder. And I start my synthetic division. -1 times 2 is -2, which gives me -3 right here. -1 times -3 is +3, gives me -19. -1 times -19 is +19. Subtracting, get -4. Multiply gives me +4. There's my 0, which verifies that -1 truly was a 0. Using those coefficients, I'm going to synthetically divide by 4 now. Bring down the 2. 4 times 2 is 8, which gives me 5. 4 times 5 is 20, gives me 1. 4 times 4 is 0. It checks. I know for sure those were my zeros. My depressed equation here is 2x squared plus 5x plus 1. And I will set that equal to 0. And decide about factoring or the quadratic formula. It does not factor. I'm going to have to use the quadratic. So a is 2. B is 5, C is 1. So in the quadratic, this will be -5 plus or minus 5 squared minus 4 times A, which is 2, times C, which is 1, all over 2 times 2. Clean that up inside, and that's going to be the square root of 17 all over 4. And as I mentioned before, when you get to that point, you might have more simplifying you have to do with the radical. You might also have to do a triangle trick at the end. What I mean by triangle trick is pretend this had worked out to be -4 plus or minus 2 radical 6 over 8. I'm just making up those numbers. Triangle trick is telling me that I would look at these 3 coefficients and see if there's anything in common. There is. There's a 2 that goes into all of those. So 2 into 4 is 2, 2 into 2 is 1, 2 into 8 is 4, which then would give me negative 2, plus or minus 1 times radical 6, but we don't need that 1. Write it down if you want, I don't care. And then the 4. And that would be the answer to that made-up problem, not that problem. Section is 3.5, which does not allow graphing calculators on this part. There's some memorizing you have to do. You have to know how to find these things. Naming a vertical asymptote is very simple. You set the denominator equal to 0 and solve. X plus 2 equals 0, which means x equals negative 2 is a vertical asymptote. Horizontal asymptote comes from this chart down here, which you need to memorize. It's the relationship of the degree of the numerator compared to the degree of the denominator. The degree in the denominator here is 1. The degree in the numerator up here is 0. So we're looking at this relationship of degrees. I'm not looking at a fraction of 0 divided by 1. I'm looking at the degrees. This is a situation where the numerator degree is less than the denominator degree, which is this right here, which tells me y equals 0 is my horizontal asymptote. To find the x-intercept, if you have a graph and you're looking for the x-intercept, that point is something comma 0. So to find the x-intercept, you let y be 0. So equation to try to solve, and I can't. If I cross multiply right here, I would have 0 equals 3, which is impossible. Or I could kind of try to reason this. There is no way 3 over anything is going to give me 0, which tells me there is no x-intercept. That's entirely possible. The y-intercept is somewhere along this axis, and the x value is 0. So to find the y-intercept, you put 0 in for x and evaluate. That's 3 over 0 plus 2, which is 3 over 2. So there is no x-intercept, and the y-intercept is 3/2 or 1.5 if you want. The domain is directly related back to your vertical asymptote. The domain is all x such that x is not allowed to equal negative 2. Once you have established that x equals negative 2 is your vertical asymptote, that means that value must be thrown out of the domain, and that's how you write it. Now, on the test, you will have to match, and what you're going to look at with the matching is look at the asymptotes and look at the intercepts, and you'll be able to match it pretty easily. So my vertical asymptote is x equals negative 2. My horizontal asymptote was the y equals 0, which is the x-axis. Also, I know I have a y-intercept at 1.5. So there's 1, there's 2, a y-intercept of 1.5. There is no x-intercept. So just from that information, you'll be able to match. In reality, we should make a t-chart and find other values to know how to graph this thing. But that's as far as you're going to have to do test-wise. For 19, it's the same set of questions. The vertical asymptote, set the denominator equal to 0 and solve. It's just a little bit more work in the solving. To solve this, you need to factor this as x plus 2 times x minus 2, which gives you negative 2 and 2. So x equals negative 2 and 2 are your vertical asymptotes. Horizontal asymptote, take a look at your chart. The degree in the numerator is 2. The degree in the denominator is 2. So it's this situation right here. If the degree in the top and the bottom are the same, then you make a fraction out of the coefficients. The coefficient in the top is 4. The coefficient in the bottom is 1. So your horizontal asymptote is at y equal 4. X-intercept, you set this equal to 0 and solve. So I'm looking at 0 equals 4x squared over x squared minus 4. Now think about this. If this fraction equals 0, the only way the fraction equals 0 is if the top equals 0. So really all you have to look at is solving 0 equal to the top, which gives us x equals 0. The y-intercept, we're going to plug 0 in for those x's. So this is 4 times 0 squared over 0 minus 4. 4 times 0 is 0 over negative 4 gives me 0. So the y-intercept is also 0. And the domain is all x such that x does not equal both of those up there, negative 2 and 2. And there's no graph you have to worry about matching up on that one. Point 6 is asking us to solve these inequalities. These are quadratic inequalities, so there's several steps we have to follow here. First off, we need to set this greater than 0. We want the polynomial over here on the left greater than 0. Factor this as if it were x squared minus 6x minus 7 equals 0. We'll come back to the greater than in a minute. So this factors as x minus 7 times x plus 1 equals 0. And we solve these, we get 7 and negative 1. And what you do with those is you put them on the number line, negative 1 and 7. These numbers here are going to help us figure out some test points to decide where to shade. So a number to the left of negative 1 is negative 2. You could pick anything you wanted to the left of negative 1. We're going to look at negative 2 being stuffed into each of those x's from a sign standpoint only. A negative 2 minus 7 is going to be a negative something. I don't care what the something is. A negative 2 plus 1 is also negative. And this is something times something, so a negative times a negative is a positive. We'll come back to what that means when I'm all done with this arithmetic. I need to pick a number between negative 1 and 7. Best number to pick is 0 because that arithmetic is easy. Put 0 in for each of those x's. 0 minus 7 is a negative. 0 plus 1 is a positive, and a negative times a positive is a negative. Pick a number to the right of 7, let's say 8, and stuff those in. 8 minus 7 is a positive. 8 plus 1 is a positive. A positive times a positive is a positive. So now we go back and think about this greater than. Numbers that are greater than 0 are positive. So I need this region shaded, and I need this region shaded because that's the ones that correspond to a plus sign down here. Also, because it's plain old greater, we're looking at the curved parenthesis. So that is my graph. The last thing is to write this as interval notation. So this one on the left will be negative infinity to negative 1, both getting the curved parentheses, union with the one on the right, which is 7 up to infinity, both getting curved parentheses. So same process over here. The factoring is just a little more involved. I'm just going to tell you what it is. It's 3x minus 4 times x plus 2. You can go back on your own and factor that whatever way you want. So I'm pretending it's equal to 0. And when I solve this, it's going to give me these points, 4/3 and negative 2. Put those on the number line. I didn't mean to make that look like a curve. So there's my two numbers. I now have to do all the test point stuff. So a number to the left of negative 2, I'll say negative 3. If I put that in up here, that's going to give me a negative. 3 times negative 3 is negative 9. Minus 4 is a negative. Put negative 3 in here. Negative 3 plus 2 is also a negative. A negative times a negative is a positive. A good number between negative 2 and 4/3 is 0. Put 0 in for each of those x's. 3 times 0 is 0. Minus 4 is a negative. 0 in here. 0 plus 2 is a positive. A negative times a positive is a negative. A number to the right of 4/3. 4/3 is actually 1 and 1/3, so a number over here would be 2. If I plug 2 in the first parenthesis here, that will be a positive. Put 2 in the second parenthesis here, that will be a positive. A positive times a positive is a positive. So my original problem was less than or equal to. The numbers that are less than or equal to 0 are negatives. The only place where I have a minus sign down here is right there. So I'm going to shade between here. Also, because it was less than or equal to, they're getting the square brackets. So there's my graph solution, and my interval notation will be from negative 2 to 4/3.